Hey, what's up, Franklin West? I have a video for you today that is all about how to understand the relationship that is existing between factoring and distribution. And this video is really the first in a short series about all the thinking and work that it takes to factor trinomials to get them back into their two binomial presentations. So there will be 3 total videos in this. This first one is all about understanding the relationship between factoring and distribution. The second is understanding the thinking needed to factor positive trinomials. And then the third one is all the thinking needed to understand how to factor trinomials that have negative terms within them. So I hope you enjoy the videos. So here's the foundational understanding that's needed when it comes to working with distribution and factoring of trinomials. Now, the suffix nomial means term or item, and so tri means 3. So we're talking about expressions in math that have 3 terms. So maybe that's a good one for me to put in right here now. So a trinomial is an expression of 3 terms. You could probably guess that a binomial is an expression of 2 terms, like bicycle, 2. And when we're talking about distribution, we're talking about creating these pairs, multiplicative pairs. So we're going to go through that process in just a moment with this example problem. And distribution is all about multiplication. So it's a multiplication process where we are just trying to take pairs of terms, so b times b as one pair, and multiply those together, and do b times 1 and multiply those together. So distribution is something you've been practicing a lot. We're doing it in an extended way, or doing an elongated distribution here by making sure we have all of our pairs created. Factoring is where we are undoing the distribution. We're undoing the multiplication process. So it feels like division, but we're not going to lose anything. You know how when you divide like 100 by 5, you just get 20 as the answer. But in factoring, you'd keep the 5, the thing you divided by, and the 20 that was your answer, because you're just trying to show still the value of that is 100 by showing now as 5 times 20. And like terms are in here as well. So these are terms that can be combined together because they have the exact same variable component or just a constant only, and therefore they can be combined. So these are all skills you've been practicing and vocabulary that you've been exercising, but I thought it might be good to just put it all in one spot here as a reference for you. This is hopefully going to be a short video. It's just making sure that we understand this relationship here. So when we are taking a look at our distribution problem as we have it here, and this is something you've been practicing, we are just trying to create all of our unique pairings to multiply. And so we use the arches, right? So b times b. So I'm going to multiply those together, and I'm going to get b times b, which is b squared. So notice this b squared is created from a multiplication event, right? And now I'm going to take that same b from that first parenthesis grouping, that first binomial, and I'm going to multiply it to the 1 over here. It's a positive 1 because of that sign there. And so b times a 1 is going to be a positive b. And now I'm going to, notice I've distributed this b the maximum amount of times that I can do that, right? I'm not distributing the b to the 7 within it, so you don't distribute within the same binomial. You just take one term from a binomial and combine it with the other elements of the other binomial until you've exhausted all unique combinations. So now we're going to go to the 7, a positive 7 here, and do the same thing. We're going to multiply that positive 7 to b and that positive 7 to the positive 1. And so 7 times b, because they're both positive, gets us a positive 7b. That's how I know to write adding here. And then 7 times 1, but they're both positive, will get us a 7. Okay, so now in this process, we will create 4 terms. 1, 2, 3, 4. But we scan it to look for any like terms, right, that we mentioned before. And so b squared, there's no other b squared term, so that just comes down on its own. B plus 7b, and remember that's a 1 hiding in there. That's a 1b. It occurs one time, but we just don't write the 1 very often, but it's hiding in there, so don't forget about it. So now it's 1b plus 7b's. These are like terms. There's a total of 8 b's there. And then there's no other number to combine or term to combine with that 7, so it just comes down. And so what we did there was distribution, right? So we did, and maybe I'll just type that in real quick. This was a distribution example that we just did. And what we created was a trinomial. So we created a trinomial by distributing 2 binomials. So that's the work that we did there. So for now, that's a bit of a recap, I'm assuming, but we now have to go in the reverse direction. What if we're actually starting with this and we need to undo that? Well, that means that when we go to undo this, we are factoring because we're undoing, and our final answer should look like this. Now, I'm not going to go into necessarily how to do it, but I just want you to get, that'll be another video. I just want you to get the experience of the meaning here. So I'm just going to show you one quick little graphic. So that b plus 7 binomial that we multiplied to b plus 1, it will create b squared plus 8b when you multiply everything through plus 7. That process of going from 2 binomials to 1 trinomial, that's called factoring. Or sorry, that's called distribution. I should have typed this so it would be faster. I'm just going to do that real quick. Okay, that's called distribution. And then over here, if we are going to go the other way and recreate what we started with, which we can do with every math process, and you've probably been noticing that this year, you can always undo what we're creating. This is factoring. Okay, so the relationship here is this undoing is what factoring is about. And so in the next videos, we're going to talk about the thinking that's needed in order to recreate the 2 binomials multiplied together from a factoring process. Well, I hope you found that video to be helpful for what you needed. Never hesitate to reach out to let me know how you're doing and what topics you would like to see next. And as always, do your best, get your work done. You're all wonderful people. Have a great day.